This is a 100 ohm resistor, brown, black, brown. Measuring the resistance. Put this on 2000 ohms down here. That works for almost all resistors, and it measures 97 ohms, which is basically the same as 100 ohms with intolerance. Okay, for measuring the voltage, I have to put the battery in there, of course, in the circuit, change to 20 volts, and I get 4.64 volts. Measure the current, take one of the wires out, put this one to 200 milliamps on the lower right, and make sure that I have good contact. 47.2 milliamps. That makes sense, because now that I have measured the resistance, the voltage, and the current, I'm going to compute the resistance using Ohm's law, where I have 4.64 volts divided by 47.2 milliamps, and I multiply that by 1000, because it was milli, to get it to 98 ohms rounded, and again I had measured 97 ohms, and the color code says 100 ohms, so all those three numbers are virtually the same within the tolerance. Alright, the other resistor. So this one is brown, gray, brown, so it ought to be 180 ohms. Again on the 2000 ohm range. And this one is really easy to measure. So 182 ohms is what I measure, virtually the same thing as the color code of 180. And by the way, to put these in, this is the way to do it. Bend it back, put it in, bend it back, clamp it in. Alright, now connect the battery. Should be the same thing that I measured earlier, because there's only one resistor and it's the same battery. So again, measure in the same fashion. 4.69 volts. Seems a little higher, I don't know why, but 4.69 is virtually the same. 4.64 as earlier. Okay, take that one out, and that's where I'm going to put the ammeter after I put it on 200 milliamps. And I have to make sure that I have good contact. Fortunately here I have the spring, and then over here 26.2 milliamp. The reason why I can use the spring instead of this one here is because they're directly connected. There's nothing in between, just a little piece of wire. So this one here yields the same result. Either way, it's going to be 26.2 milliamps. And then to calculate, again, Ohm's law, 4.69 volts divided by 26.2 milliamps times 1000, and I come up with around 179 ohms computed, which matches my measured resistance of 182 and the color code 180 ohms, all within tolerance. There's like a 1% difference between them. And then I forgot to actually compute the power, so I'm going to do 4.69 volts times 26.2 milliamps. That's the formula for the power. This time around I'm not going to convert it to watts. I'm just going to leave it in milliwatts, so I'm just going to call it 122 milliwatts. And as I said, I forgot it for the one earlier, so 4.64 times 47.2, and that is 219 milliwatts. And that is how table 3A is completed, and you saw how to measure the resistance here. Of course, putting it on resistance. I'm just going to turn it off for a moment. Put it down here on resistance. This is also how the voltage is measured. Of course, you have to connect the circuit then. Well, for resistance it has to be open. And then to measure the amps, as you put it over here, you connect from here to here. Wherever you break it, that's where you connect it. Again, here you have the luxury of putting it to one of the springs, and that's where you measure the